Okay, in 1.5, we're going to be looking at quadratic equations. And when we say the word quadratic equation, it's an equation that has this form right here. So in other words, you have an x squared. To be considered quadratic, it must have an x squared term. A, B, and C are your coefficients. They're your numbers. And A cannot be 0, because if A was 0, you wouldn't have an x squared term. So these are some examples. You can have them in solvable forms that equal to 0. You can have them where you may have some terms on one side, some terms on the other. But the key, and we'll talk about this shortly, is in order to solve it, you need to have it in this format. So you got to have all terms on one side set equal to 0. So we've got one of the four methods we can use to solve a quadratic equation. We can do by factoring, square root method, completing the square, or using the quadratic formula. So if we want to first look at solve by factoring, that's the preferable way. Obviously, if you have trouble factoring, it may not be the preferable way, but if you can factor, it's the quickest way. Not all quadratic equations can be factored, but if they can, it's way quicker. And we use what's called the zero product property to solve these. So why do we set it equal to 0? Because if we can factor it, we can say, well, if you have two numbers multiplied together to equal 0, then one of them has to be 0. Okay, and so that allows us to solve better. Now, you can't do that for any other number. It only works for 0. So before we get into the solving part, let's practice some factoring. So again, there's no equal here, so you can't solve for anything here. We can just factor. So the trick to factoring, if you do have trouble with it, we always look for a greatest common factor. There aren't any between these three terms here. And with this being a 1 for my x squared, then I look at factors of 6 with a sum of 5 because everything's positive here. So 3 times 2 is 6, 3 plus 2 is 5. So there are my factors. So you're satisfying two requirements. For this one, we are satisfying two numbers that multiply to give you 6 that add to give you 5. When we have a minus sign on the end value here, that tells us that we're going to have different signs. We're going to have a negative and a positive. Since the sign of this is negative, what I'm looking for two numbers that multiply together to give me -8 with a difference of -2. Well, -4 times +2 is 8. -4 and +2 is -2. And if you're ever not sure if you're right or not, well, FOIL it back out. Okay? X times x is x squared. My outers is +2x. My inners is -4x. And my last is -8. If I combine these terms, I'm going to get what I started with. That's what you're doing when you're factoring. You're trying to find two or more numbers that multiply together to give you what you started with. The third example of factoring, since, again, this number here is positive, then our factors have to have the same sign, and this tells us that they both must be negative. So if you think about it, I'm over halfway there. So I need two numbers that multiply together to give me 12 that, again, add to give me 7. And in this case, it's add to give me -7. -3 and -4 is -7. Okay? So, and we will do more of these. But this is just some practice. Now, if I want to solve by factoring, I first have to get the equation set equal to 0. So I must subtract that 24 to get my equation equal to 0. Now I factor. So again, as we talked about earlier, if this is negative, my signs are different. So I need two numbers that multiply together to give me negative 24 with a difference of positive 5. And that would be positive 8 and negative 3 equal to 0. Then I use my zero product property where x plus 8 is 0 or x minus 3 is 0. So I subtract 8 to get negative 8 there. I add 3 to get positive 3 there. So in this case, I have two solutions. So example 3. Set up my two parentheses. I need factors of positive 20. And since this is plus, these signs are the same. Since this is negative, they're both negative. And so now I need numbers that multiply together to give me 20, that add to give me negative 9, negative 4, and negative 5. Continue to solve using my zero product property. So x is 4 or x is 5. Okay, so that's solving by factoring. That's one method we can look at. Another method we can look at is the square root method. Suppose we have an equation in the form where you have something squared is some number, x squared is some number, or you have a term inside parentheses squared is some number, again where p is not negative, then we can use the square root method. We take the square root of both sides, giving the positive value of the square root and the negative value to get our two solutions. Now you can still set it equal to 0 and try to factor, but again, this is a time saver. So if I have x squared equals 16, I just apply this rule right here. Then I know x is the square root of 16, or x is minus the square root of 16. Because when we're solving equations involving a square, we can square a positive value and we can square a negative value. So we get x is 4 or x is negative 4. And also with the second power here, that tells us there's two possible solutions. So when we have a setup like this, we still apply the rule that's right here. So x minus 2 is square root of 9, or x minus 2 is minus square root of 9. Take the square root of the 9, because we still have to solve for x. Add 2, so x is 5, or x is negative 1. So try to just get the basic process, and then we work on, different types of examples when we meet. Okay, so we just want to get the basic understanding of the process to follow. We'll deal with different values in class. Another way to solve a quadratic equation is using the quadratic formula. Now, this method works for any quadratic equation. It's a little more time consuming. There's more room for error based upon, squaring numbers, subtracting, multiplying, setting it up correctly. But it does work for everything. But sometimes, there are mistakes that can be made getting your values correct, okay? We call this expression underneath the square root the discriminant, okay? It's set up, the way it's set up is x equals minus b, the opposite of b, then plus or minus. That's how we get our two solutions. And, I always say the best way is to evaluate this number first, put it in there, and then go on and simplify or whatever you need to do further. What we know is if this value, whatever we get for the b squared minus 4ac is positive, it's bigger than 0, then we have two solutions. If it equals 0, then we have one solution. If it's negative, we have no real solution. And we also have to set it equal to 0 as we did for our other quadratic factoring. So it also is true for quadratic formula. You must set it equal to 0. So if I have this first example here, it's all in the proper format. And, you know, I see students make these kind of not necessarily mistakes, but just, you know, not paying attention to details. All of this should be in the numerator. What I see is I'll see students put just the discriminant over the 2a. Everything is over the 2a. Okay? Now, from my equation, a is 3, b is negative 5, and c is negative 1. So I substitute. Minus b plus or minus b squared. Make sure you put that negative 5 inside parentheses if you're using your calculator. If not, it can square it and leave it negative. Sorry about my writing there. Minus 4 times a times c. All over 2a. So if you want to pause and see what value you get under here, then come back to it, go ahead and do that, because that's normally the most difficult part, is to, you know, put this into your calculator. Calculators are great, but sometimes we have to make sure we know how to use them. So if you have paused and you've come back, hopefully you've simplified this, but minus negative 5 becomes positive 5. Underneath my square root is 25 plus 12, which is 37, all over 6. So that's as far as we can actually simplify that. I mean, at some point in time when we plotting points, we can take the square root of this number, make it a decimal, and get an approximate answer. But for right now, our two solutions are 5 plus the square root of 37 over 6, or 5 minus the square root of 37 over 6. What we sometimes want to look for is, you know, can we factor this square root? You know, is there a factor of a 4 or a 9 or a 16, 25, etc. that we can factor out of this? And there's not, so that's simplified as far as we can go. Okay, the next one, we have our quadratic equation, but it's not set equal to 0. So what I need to do is I need to move the minus 12x and minus 9 over to the left side. So I add 12x to both sides here. I add 9 to both sides. And then what I get is a quadratic equation set equal to 0. Use the quadratic formula. So x is, and let me go real quick, backtrack a little bit. A is 4, B is 12, C is 9. And, you know, A is always times x squared, B is always times x, C is by itself. It doesn't matter what order they're in. It goes by what coefficient they are of. So we've got minus B. I think I'm going to run into my other equation. Plus or minus b squared minus 4 times a times c all over 2a. Okay. So I've got minus 12, and what happens under here is I get 0. So this is an example of one where the discriminant is equal to 0. We're only going to get one solution because minus 12 plus 0 is minus 12. Minus 12 minus 0 is still minus 12. So my solution is negative 12/8, which reduces down to negative 3/2. Okay. And also, when we get a perfect square underneath the square root, that tells us we could have factored it. Okay, that's just an FYI. Lastly, I just want to illustrate this one to show you one where you're going to get no real solution here. So A is 1, B is 2, C is 2. Substitute minus B plus or minus the square root of B squared minus 4 times A times C all over 2A. And when I work this out under here, I get negative 4. If we were doing imaginary numbers, we could work this out. That would be 4i, and we would go from there, but we are not. So at this point, there is just no real solution. Now, the imaginary numbers, we could get a solution, okay, but we just say no real solution. And that's as far as we go with once we get a negative under the square root. So that's it for this one. And, we will, again, as always, do more practice.